Okay, limits with trig. When you look at the limits with trig one, we have to remember what the one you proved with your sandwich theorem that you can use now that says the limit as x approaches 0 of the sine of x over x is 1. Keep that one in mind, okay, as we go through. So, when I do one like a tangent of x, I need to think of, okay, how can I get sine involved with that? Well, I can say this is the limit as x approaches 0 of the sine of x over the cosine of x. That's what tangent is. So I'm just replacing tangent with sine over cosine. Alright, so that gets sine into the problem. So now I look at this and see that I have a complex fraction. So let's multiply by cosine x over cosine x. So you're just going to be doing this in algebra after you do your trig substitution, and you get limit as x approaches 0 of, this goes away, so I get sine of x over x times the cosine of x. Okay, so you're left with that in the denominator. In the numerator, those cancel out. So now I can look at this and split it up and say this is the limit as x approaches 0 of the sine of x over x. I can group that together times what's left over, which is 1 over the cosine of x. So now I can evaluate the limit of each of these separately. I can take the limit of this, which I know is 1, and then with the limit of this, I can use substitution. So I need to show that step that this becomes a 1, and I have to write that I've evaluated that limit to be 1. And then to evaluate the limit of this, I can take 1 over the cosine of 0, and I have to show that I'm substituting in a 0. Cosine of 0 is 1, so I get 1 times 1, and I get 1. So in all of these, you're trying to get the sine of an angle over itself, because you know when you evaluate that limit as x approaches 0, it's 1. Alright, now when you get to ones like, let's look at 7. This says limit as x approaches 0 of the sine of 7x over x, and you can't put substitute in the 0. So we need to, if we're going to use that limit that we have, we need to make sure it says limit as x approaches 0 of the sine of 7x over 7x. That would be 1. So to get to that, I'm going to multiply by 7 over 7. So that becomes the limit as x approaches 0 of 7 times the sine of 7x over 7x. So I'm grouping these together with the sine of 7x. And so now I see that, okay, when I want to evaluate the limit as x approaches 0 of 7 is just 7 times the limit as x approaches 0 of sine of 7x over 7x is 1. And again, I have to show that I evaluate the limit of 7 is just 7. The limit of sine of 7x over 7x as x approaches 0 is 1. Show both of those, and then you can give me your answer of 7. So with some of these, you have to do some multiplying so that you can get that to be the sine of an angle over itself. So you can evaluate the limit as x approaches 0 of 1. So there'll be some trig identities involved here. There'll be some multiplying where you have to get your fraction to look like that. So that's really this whole worksheet. There'll be some double angle possibly, some half angle. There might be some factoring involved. So there's going to be a few other tricks that you're going to have to deal with, but I'll let you try some of those, and then if I need to, I can do a video on any of the solutions that you have. But that's really all there is to the trig ones.